Ledge Runner Part 1. In this tutorial we will create another game I usually teach beginners how to make. I call it Ledge Runner. Let's show you how it looks like. It only has button controls. So you have this guy. He runs on ledges and you need to get more points. And you need to avoid going over the top of the screen and the bottom of the screen. Basically, you need to stay on the screen. It starts slow, but every 1000 points it gets faster and the ledge's color change. You'll see in a moment. Oh, that's the new ledge. You don't want to get caught between two ledges either. See, it goes faster. The challenge goes up every 1000 points, you'll see in a moment. When it will change to the lava ledge. Basically that's the game we will create. It will require a lot of the code that might be found in a platformer, like oh, don't lose. Oh. So basically you can hit a ledge from the... I lost. You can also lose by falling down. Let me show you. I want to show you another thing. You can't go through a ledge from the side, the bottom, from any side. It's like a directional collision. I don't think there is any example for this in AppGameKit. Usually this would be done, I think they expect you to do it with their physics. Like you see, you have gravity. Like here I'm going down. Gravity. So yeah, basically... Oh, and another thing. Oh, no, I didn't lose. Okay, so I can show you. I press and it continues moving after I stop pressing. That's velocity and friction. So basically, yeah, it's also a mini, very basic physics engine with velocity, friction and gravity. And also you can't go through solid objects. Basically they wanted you to use Box2D for that, but I want to teach you how to do that from scratch. Like any monkey can use Box2D. I want you to be able to I don't know, program a platformer or a game like this with basic physics from scratch. So let's see what we have here. We have a few images. The grass, the purple blocks, the lava, and the runner guy himself. It's an animation, and when he moves, this animation is for the right side, but when he moves to the left side we use a function that flips the sprite. So basically it goes for this animation when you press left or right, and flips if needs be. So yeah, we'll also see sprite maps here. So in this lesson I'll only code the boilerplate code. So let's start by initting the images. So we'll need to use well, first I'll do the IDs of the images. Global player img equals 1. Let's do this a couple of times. Grass img the purple and the lava. Two, 3 and 4. I think we only have 4 images here. So the player will be a sprite map, but that's okay. You can load it as an image and later give it the frames and set it as a sprite map. we already done this a couple of times if you've seen my tutorials. Runner.png, that's how it's called, the image, runner.png. Okay, so let's duplicate this a couple of more times. Let's see, grass. And the logo. So now I want to do the sprites ID. This one will be different. The way I'm going to plan this. So the global player ID, player sprite ID will be 1 always, but for everything else we'll have a global sprite counter that we will increment every new sprite that we'll add. It will start from 2 because player already has 1, so if we want to spawn a sprite we'll use this, and then we'll increment it, so it will be, instead of 2 it will be 3, 4, 5, and that way we don't need to worry about sprites IDs. And we'll also need a ledge array. That will hold all of our ledge types as ledge array. But we don't have a ledge type, so let's make one. We'll have an ID for now. We'll see if we will have time, we'll code its attributes. So let's see what else. Game variables. So we'll need, in my original game I had power-ups that changed the gravity, stopped the gravity, reversed gravity, etc, etc. So I had to keep the original gravity on a separate variable. Original gravity. So the gravity is a float. And the current gravity, like at the start it will be equals to the original gravity, but it may change by a power up to minus the gravity, and then when the power up is over it will be changed back to the original gravity. So that's very comfortable. So the original gravity will be 1.6 pixels per tick, and the gravity itself will equal to the original gravity at the start. And we'll need something to hold our ledge speed. Like every ledge has its own speed, but there's a global speed that goes up and given to each new ledge. Like let's say 1,000 points have passed and the ledge speed goes from 1 to 2. So now every ledge that spawns will have a speed of 2, and then the ledge speed goes up again. So it will be 4. So now every ledge every new ledge will have a speed of 4. So we need something to hold this. Global ledge speed. To start it will be 1. And we'll need a global variable to hold our points. And also a game over. Like we did in the avoider game. At the start it will be 0. And we'll also need timers, again like in the avoider game, to spawn our ledges. So timers. It will be a float. We need another variable for the counter, the end of the timer. We'll call it done. So basically this will hold the end time of the counter. So every 5 seconds a new ledge will spawn. This is important because the space between the ledges will also be determined by the spawn timer. Like if it's short, they will have a very little space between them. So I give it 5, so you'll have a lot of space between ledges. Maybe you would want to change it. Like the faster the ledges are, I think the less or more space they'll have between them. So you'll need to find a way to balance this. Let's see. You'll see in a moment when 2 ledges will spawn. 1, 2, 3, 4, 5. You see they have a space between them, the 2 ledges. This is determined by the timer. So if the timer is shorter, I think you'll have less space and the runner will get stuck. This way he can move between ledges easily. Okay, let's continue coding. The spawn timer done itself will be the game's current seconds plus the duration. It's called get seconds. I covered this in our avoider game tutorial on how to create timers. If you don't remember, you'll see when we'll get to it. But basically you'll need to have a duration and the end of the timer, and then you need to check it against the current time. Spawn time done against current time, and to reset it you just copy this and put it wherever you want to reset the timer, and it will reset it to the current seconds plus the duration. Okay, let's see. So let's start by showing the points the lazy way with print. And let's do the game over. That's easy. Usually in a real game you would want where's game over? Game over, here it is. If game over is 1, don't need to write 1 because 1 in AppGameKit is like true, so 1 is true, 0 is false. That's how they do it in AppGameKit. Let's see now. Print game over. So basically in a real game, what you'd want to do here is to change to the game over screen. Or not, depends on the game. That's when the game is not over. When the game runs, we'll put here all the functions that runs when the game is not over. Let's see. So we'll want to increase the points. All the time. And we'll wanna do a player update. To update all of the players' functions and position and whatever. Let's see. Move ledges. Yeah, I don't want to call it a ledge, I want to call it a Y ledge, so add a Y before the ledge type. Just to prevent any slight chance of name clashing of any sort. And spawn ledges. So here will be the player functions. And here will be the functions for the ledges. So let's create function, this one. We would also want to create a type for the player. This time the player will also have type because he will need to have velocity, friction, and all that good stuff. Okay. Type Y player. So it won't have a chance to clash with our player variable. You know, the global player variable that we will manipulate in all these functions. It will be a Y player. So Y player will need an ID, the sprites ID, and speed. It's global speed. It will also have a speed for the X and the Y. So basically it's the speed that it needs to move by in this stick. It will be like the speed and some calculation with the velocity. So velocity will need vertical, friction. Vertical friction as flow. And horizontal friction. So basically the velocity X and Y will be this. Maybe I should call it Vx and Vy. That will be confusing with the Vf. So we'll call it speed X and speed Y. That's the velocity vector to be affected by the gravity vector. You will see when we'll get there. So I don't like creating a type by hand, so I'll need a function called new player. and we'll have a player move. To handle the player movement and clicking the buttons and whatever. So let's see. We'll put player move in update. And we'll also want a function to check the player's boundaries. You know, when it hits the left or the right side of the screen, I don't want to let the player get out of the screen from the left or the right. Or if it gets out of the top or the bottom, game over turns to 1, because it's game over. So we'll also check the player boundaries in update player. I'm putting all of them in player update instead of putting them here. You know, like 100 functions, I'll just put one function that relates to all the players, all the player methods that needs to run in an update, and so I'll call it a player update. This will run all the methods that needs to run every tick of the game loop, every iteration of the game loop. So yeah, every iteration of the loop you need to run player move and player boundaries, and what else? And that's it. We'll also need a special collision detection function for you know, directional collision detection. I'll show you how to do that. You basically need to predict where the player is coming from. By default, AppGameKit does not have this, so we'll have to code this from kind of scratch, almost from scratch. They have rectangular collision, but yeah, they didn't even plan doing something like that, like a directional collision. Like who uses that? Like if collision from the right, left, or top, like only 1 million games. I don't know why they didn't. Well, AppGameKit has a ton of features. This one can be coded by hand. I'll show you how. It's not that hard. I could have done all of the collision from scratch, but because they have a rectangular collision, it should be easier. Let's see what else can we write in our boilerplate code. I think that's it. Like the hit prediction. Oh, we'll also need Signum. AppGameKit doesn't have Signum, but it's very easy to code. So I'll show you. It's called Sign. If you ever programmed, you're probably familiar with it. It's a math function. And yeah, we'll have a lot to code. So let's finish here with bare basic boilerplate code. That's it for this lesson. If you have any questions or something, please contact me via the comments or the AppGameKit forum or my contact form, or any way you can.